Hi all, and it's great to have you at our second chapter of Polkadot India Substrate Saturday Bootcamp. That's a highly competitive Rust and Substrate training series within the country. A very big welcome to all of you, and especially as the very first batch or cohort that's doing this. So congrats on picking this up at a very promising stage and a very early stage, and we are with you through your entire journey. Now, please note that we have an exclusive Discord channel for developers. So do fill in the form in the chat box and stay connected. And for those of you who are already on it, why so serious, guys? Keep it interactive, ask questions, share knowledge and views, participate in assignments, and don't shy away because we are all learning together, right? Now, a quick game, and you have exactly a minute to do this. So we want you to follow us on Twitter if you aren't already. Retweet the pinned post about Substrate Saturday with 5 lucky draws winning a surprise that you don't want to miss, right? So exactly a minute to do this. Follow us, retweet the pinned post, and get lucky, 5 of you, right? Now, for the fun part of this bootcamp, we'll also be shooting out 3 quiz questions at you through the evening. Post your answers on Twitter, tagging us at #.friday. At Polkadot India, and 3 winners per question grab exciting PEI giveaways again, right? So now, do we have the first question? Can we have the first question? Right. So what is the behavior of these syntax and self and mute self? A, both can be modified. B, both values are owned value. C, both modify the reference to the original value, and D, only a reference mute can modify the original value, right? So again, answer on Twitter by tagging us at #.friday with your right options, and we'll get in touch if you win. So that's 3 of you taking this away, right? Okay, now, so Substrate is built on Rust programming language, which makes the novel design patterns to enable the development of code that is safe and fast, right? Now, although you don't really need the knowledge of, Rust to get started with Substrate, a good understanding of Rust will always allow you to become a better Substrate developer, right? But what does it take to be a developer in the world of blockchain, Web 2, Web 3, the metaverse, and the likes, right? It's these skills of Rust and Substrate. And that's what we are here for, to give the skilled and desired Indian developer base an edge over many with this focused training. Now, before I pass it on to your trainers, we'll be sharing an assignment just like the last time within a few days on the Discord devs channel. So make sure you join it. And just to make it a little more exciting for you this time, the top 3 submissions win about $50 worth of .eth. So get that code cracking this time around, guys, and we'll be looking forward. I now give you your mentors and the curriculum designers of this bootcamp, Varun and Loakesh, the brains behind some of the most interesting upcoming Indian crypto projects. Guys, this is amazing what the team is out here to do. And over to you now, Varun, and they're all yours.
Thank you so much, Ananya. I would like to welcome everybody onto the second bootcamp session that we are hosting for Polkadot India, which is Substrate Saturday. I just wanted to gauge our audience, like how many of the people are actually from the previous bootcamp as well, and who are the new joinees over here. If you guys can just raise your hand or something so that we can analyze and assess, so that we can plan the curriculum that way also going forward. Okay, any hands?
Yes, we have about 32 people. I suppose these guys are repeating when they have attended first bootcamp, I guess.
Okay, perfect. So for rest of the people, welcome again. And for the previous batch of people, welcome again. And for the new joinees, thank you for joining us this time. And I would guarantee you, I would assure you, after this particular session, most of you would actually understand some advanced concepts of Rust, and also would get a decent hands-on understanding on Substrate, which we would cover in the overall session. And you never know, after this particular session, you might actually end up launching your own blockchain using Substrate. So that is how the curriculum is designed. So before we get deeper into this, I would ask Loakesh if he's available to take on the advanced concepts of Rust. This would be around a 30 to 40-minute session from our end. This is an important concept for you to end up picking up on Substrate, because Substrate is heavy on the concept of traits. What are traits? How to implement those traits? Loakesh will take it forward from here, and then we will take some questions on that too. Okay, over to you, Loakesh. Do we have Loakesh already?
Varun, meanwhile, there are quite a few people who are joining in.
Sure.
So can you touch upon what we did last time?
Last time we basically understood how to create your own types and how to utilize those particular types into your Rust code base, how to customize those types. So the types which I'm talking about were basically structs and enums. And then there was the generic structs that we created, and utilizing those earlier concepts, we are going to merge that concept into the interface, which we call in different languages, like, or an abstract class that we create. Those are nothing but those are traits in a Rust language. So I believe Loakesh is already over here. So Loakesh, you can take it forward and demo the audience with that. You guys can actually provide your responses in the chat if you want, or raise your hand. We can unmute you.
I think Mani Gupta is asking to be unmuted. So,
am I audible, ma'am?
yes.
Hello.
Yes, Mani.
Hello, ma'am and sir.
Hello, hi.
Yes, sir. I am actually new. I am first time joining here, sir. I am unable to understand that you gave under assignments of NFTs and what. Sir, can you please tell in brief? And also, sir, I have made three NFTs, but three NFTs, and also I have launched it in OpenSea market.
So like when you say that you have created 3 NFTs, so have you minted 3 NFTs, or like did you code 3 NFTs using a particular language?
No, sir, I haven't coded. I just made a picture, like downloaded it from Google and made some edited, and I launched it on OpenSea market.
Did you make some money?
No, sir, no one has bought my NFTs till yet.
Okay. So what is your question about?
Sir, first of all, I have a question that is this workshop or anything is paid, like for how many, the course is for how many months?
So currently we are in the 2nd month of our course. In the 1st month we covered some basic concepts on Rust, which is a programming language which it's a systems level programming language, just like your C++, but much more memory efficient. And why we are doing this? Because as the name suggests, Polkadot India. So Polkadot is a blockchain which is natively built on a framework, Substrate, which the underlying language used by Substrate is Rust.
Okay, sir. And sir, so I am first time I am joining here. So sir, when the 2nd batch will start, means again any other batch will start, so that I can again also learn Rust and other types of languages.
It's never late, my friend. That's the reason we are doing these sessions. So if you could just stay with us, we will help you guide from the starting point to the end point. So just stay with us, because we will be covering not only the advanced, but also some basic concepts for you to pick up on Rust. And then eventually we will help you migrate to the level of Substrate code base. It would be easier for you to actually stay and learn with us.
Okay, sir. Thanks, sir. Sir, one more doubt which I have, last question. Sir, can you please provide your LinkedIn ID or any contact information so that I can contact? I will not contact you, means whenever it is much required, then only I will contact you, sir.
Sure. I believe we already have LinkedIn IDs shared with everybody, but we'll reshare it again, probably onto the chat itself, where, I mean, you can ask questions separately also, not a problem.
Excuse me, sir.
Greetings, sir.
So am I audible?
Yeah, Manvendra, yes, you can go.
Thank you, ma'am. Greetings to everyone. Sir, actually, I'm totally new to this NFT and everything. So I have a basic question like, what is the difference between minting an NFT and coding an NFT? If you can answer it. Thank you.
So see, okay. So for example, the earlier caller, like the person who was speaking, I'm sorry if I'm not able to recall the name. So creating an NFT on a marketplace is basically you can actually download any image or you can generate any image, and the front end is actually helping you to mint that NFT via a contract, right? On the other hand, creating an NFT beforehand or to be deployed it onto a decentralized storage and then minting it via your contract, that's a separate game altogether. That is what most of the people into NFT marketplaces and NFT spaces are actually trying to do. And that is the reason the value of that specific NFT is increasing day by day, because you are at least sure that there's a single copy of it. But as the earlier caller mentioned that I just downloaded it from Google, and so there could be thousands of people doing the same thing. Correct?
Yes, sir.
Yeah. So when you're creating it from scratch, that mintable option of creating an NFT gives it a unique value, a single value, which is stored on a decentralized storage without any central authority taking care of it, which is what OpenSea does. If you sorry.
No, I think that was offline. Yeah.
Okay.
Sir, am I audible?
Yeah, you're audible.
Sir, I'm experimenting with Hyperledger, not specifically with Rust, but Hyperledger. Actually, I want to know, is Hyperledger my good bet to start? Like, I'm just starting as a developer. I know bit of C++, I know bit of Python. I don't know anything about Rust or anything. I feel I don't know even web development. I've just started with Hyperledger. So is my Hyperledger good bet? And should I continue with it? I know a bit of Solidity as well, but I'm facing barrier in front end part because I don't know web development. So can you help me out? How should I go or anything like that?
So see, there are major differences between the technologies that you have spoken. One is Hyperledger, and the other one one is a permissionless blockchain.
Yes.
Hyperledger is a permission blockchain, right? So that is majorly returned based on proof of authority. On the other hand, also on the PBFT, on the PBFT, you have written the consensus for a POA. But on the other hand, the other blockchains, which are public and permissionless blockchains, they have different consensus and different approaches. You don't with your Hyperledger, it could be up and running and managed within with 7 to 8 nodes itself. For a local testing and even for a proper deployment. On the other hand, in order to manage the speed and the transactions onto the public blockchain, you need at least I don't know, I can't say the number, but around minimum 50 to 60 nodes in order to provide that speed and connectivity. Correct. Now, starting as a developer, it is purely on you which platform you are comfortable with. But at the end of the day, core concepts of understanding blockchain remain the same, even if you're working with Hyperledger, even if you're working with Solidity.
I'll explain you my end goal. I want to create my own network, as in even if I go completely on like Ethereum or as in Ethereum, Polkadot or any other language, but I want to not just be on front end, like as a developer, just create smart contracts and build front end for that stuff. I want to create my own network, as in own my cryptocurrency or as in own my blockchain. So how should I proceed with that?
I believe you have already answered that on your own. So if you're not interested in front-end development, and if you're just interested in writing contracts and understanding the flow behind the backend integration of your contracts, making that communication with each other, then Solidity is a good bet to go ahead with. But
Solidity, as in I have to learn Node.js or different no, not necessary.
No, not necessary.
Because
in order to test your contracts, you can actually deploy it on a front-end development, which is a front-end tool that is already provided by Ethereum, known as Remix ID.
Yes, Remix ID.
So you can actually, yeah.
That's just the contract part. I'm actually looking forward much more forward. Like actually, I want to build my own Ethereum as in like smart contract is the part, but as in setuping nodes, like setuping nodes, network, creation of like tokens. How can I proceed with that? Like as
So
in my own network.
you don't need Node.js for that.
Actually, I'm damn confused because the resources online are damn confusing.
Do one
Actually,
thing. I would suggest one thing to you. Sorry to cut you in between. I would be demoing that same thing, whatever questions you have by the end of this session.
okay,
Okay.
fine, sir. Thank you.
So you can ask your questions immediately after that, if that answers your question.
Okay, sir. Thank you.
Cool.
So also if you guys have any questions.
Hello, sorry,
join
can I
our
ask a
Discord
question?
channel. Please join our Discord channel to get access. Fill this form now, the one which is in chat. So you'll get access to developer Discord channel. Thank you. Varun, we can get started.
Sure. All the questions could be taken care of at Discord, as Harsha has already mentioned. So without wasting much of our time, and let's jump directly into the implementation part. So over to you, Loakesh.
Yeah, thanks, man. Yeah, good evening. And yeah, so basically, so before I start off like doing some coding directly, let me just, I mean, for all the people out here who are new to Rust, I'll just give you an overlook of what basic Rust is. So yeah, let's start with that. And do ask a question as in when you are doing it. So this is just a small recap of what happened in the previous bootcamp, and I'm only doing a small part of it on what Rust is. So yeah, so if you see, yeah, so, yeah, so this is how I mean, like the syntax, like, so you all begin with the hello world program. So this is how I mean your print statements are written inside main function. You just write the macro. So something that that may be unique here is, like, you see that there's print ln and then there's a exclamation mark, which here in Rust denotes that this is a macro. So what are macros in Rust? Macros are like small modules that take some parameters and do some execution in the back. So that is as simple as a definition I can give you. And yeah, so this is about it. And this is a command on how you execute the program, right? So yeah, and moving on. So defining a variable, like, how do you define variables? It's pretty simple. You'll use the let keyword. So in Rust, like all other languages, you also have the let and the const keyword. And the const keyword is used whenever you want to define a constant. And the let keyword is used whenever you want to declare a variable at the local scope. Consts are declared at the global scope. For example, so just leave all these things. So if I were to write any basic variable that I want to do, so I would start off with saying let x is equal to 1. So right, but can you see that it is throwing an error right now, right? It's already throwing expected item but found let. So like I said, let is a keyword that you use while declaring variables inside a function. So now the variable is gone, it's unused basically. But yeah, and that is about let keyword. And similarly, if I can do the cargo run for this, yeah, so yeah, so now if I were to compile this simple program, and so yeah, so if you see, this is like a basic print ln statement, and I have defined the keyword let here. And like I said, the scope for const keywords are on top or global variables. So if I say const, say session name is is an and str, and str is a string type, and say it is on bootcamp 2, like traits, right? So that is what my session is going to be about. So now you see when there was no error throwing here. So basically that is the difference. Const keywords are having a global scope. It can be on top of the file, while let keywords have a local scope, which is inside your functions that you're writing, right? Yeah. So this is a simple thing about declaration of variables. And yeah, moving on. Strings, like I said, there are two types of strings. One is and str, and the other one is string. So you can also write a string like this. So let y is equal to uh, y is of type string, which is equal to string from hello world. So there is only one difference between the string you see here, that is and str, and the string here. So here string is a custom type in Rust, which is an owned value. Means this string I can I have complete ownership to this. Like in the previous session, there's the concept of borrow and ownership model. So with reference to that, so basically any variable that is sent or used in a function will lose its scope, I mean ownership, the moment it is utilized. So it will have only one instance of it ever created. So that is my line number 11, where I'm saying a string type. Got it? And this and str is just a reference to my string type, which is traits, which I can always call at since it's a constant here, I can call it a global scope. So this is a basic string type, and other than that, you have some types like your regular type can be an integer of 32 bits, or I64, or I128, and what else? 16, I16. Similarly, you have unsigned integers, I32, and all the iterations of the same. Yeah, so these are all your unsigned integers. Similarly, you have floating point numbers, that is 1.0. So like, yeah, these are your floating point numbers. Yeah, so basically this is how it is. So these are this is just a simple overview of how you what are the primitive types that are used in Rust, and how functions are. So, and like all programming languages, you have a main function which starts off your executes the at runtime the entire library that you've written, or any function that you've written. So yeah, and moving on, so calling functions, like I said, this is pretty simple. You write a function add, and you can call it in the main function, where it is going to be executed by saying result A and B, and yeah, print this one. So let me just write it quickly for you guys. So function add takes two parameters. X is an I32, and Y, which is also an I32, and it returns. So this syntax, the arrow mark here, is a return statement. So you should in Rust, you should always mention what are you returning from your function. So I return an I32 only. So what I'm going to return is X plus Y, right? So, and if you notice here, I don't know, do any of you have any questions at this point of at this juncture so far? You can observe something here. I told you the function must return a value, that is I32, but can any of you come up and tell me why am I returning something, or am I doing something wrong here? Can
You guys can post your questions on the chat.
Yeah,
we don't need the semicolon at the end.
okay, so if you're going to say that, like, can you tell me why? So why do I know? Well, I mean, what is the difference between writing a semicolon at the end of the line and not writing it in a function reference?
Semicolon denotes that it's terminated. Like we put it in the end of the statement.
Got it.
Yeah, actually in Rust, we need not to explicitly return something at the end of the function. Like in Rust, if there is no semicolon at the end, it is automatically returned from that function.
Oh, yeah, actually what you said there is correct. So, I mean, whatever he explained is correct. So in Rust, if you write something at the end of the line of a function, of any function, say if I'm going to print this line here, and yeah, yeah. So someone was calling out.
No, I think that's
You can continue.
no,
Okay,
we can
got it. Sure. So the point I was trying to make is that I can write anything above the last line. So only the last line, if I do not end it with a semicolon, it is self-understood that I am returning whatever is the last line. The last line is being returned. So now I have another question for whoever it was answering. I'm sorry, I'm not able to see your names, but yeah, please come ahead and tell me. I want to return the same value with the semicolon. Can you guys tell me how do I do that? So there is a semicolon and it is throwing me an error saying mismatched types. Expected an I32 but found a unit type. Means I'm not returning a value. So could any of you come up and tell me how can I fix this? How can I return this value and fix this error?
Can you can type in your answers in the chat box, please?
So this is the error, right? It's saying it implicitly returns a unit, which is basically nothing as its body or tail, while it's supposed to return something. It's supposed to return an I32 value. Yeah. So yeah, correct. I just need to write the return keyword. Use the return keyword and the error is gone. So yeah, so basically these are the simple like stuff in Rust, and this is a more handy syntax, right? You don't need to always say at the end of the line, like I mean at the end of a function say return. So yeah. So this is a simple add function, and now say I want to call it let a comma b is equal to 10 and 20. Now println result is equal to the value of add, and I pass a comma b, right? So now if I compile this program, you can see I've got a value that says 30 here. Is my screen visible, and am I clear? Ananya, can you just tell me, am I
Absolutely,
audible?
you're absolutely
Oh,
audible. Yeah.
okay, got it. So yeah, you can see that a plus b 20 is 30 is executed, right? So this is how you just write a simple function and call it at main level and call the function in this particular manner. Yeah. And any questions here? Any questions until here? I mean, you're seeing the code, and any questions here in any of the syntaxes that you don't understand? So sure. So please go ahead and type the questions. And people who are not interested and here to waste time, I would suggest you to leave. Yeah. And moving on.
So that Lokesh.
Yeah. So yeah, I've already covered the primitive types, and these are the simple representations of how anybody would write a loop. So there are a for loop, a while loop, and an infinite loop. So there is a special feature in Rust which says which has the loop keyword. Basically, it is similar to a while loop, but only thing is you can define to do something at computation. So this is using the loop keyword. This is a while keyword, and this is the for keyword, for loop. So here, if you see the first for loop, it's a for a value in 0.5, which means it is 0 in range until 5. So each of this value will return the number itself. So if I were to print the same, use the same code, Yeah, and if you see here, so this supplement is going to print each of the values from 0 to 5, but it's not going to print the last element. So if you see here, so you can see it only prints the elements between 0 to 5. So that is 1 to 4. So now if you still want to add, like most of the people when you're coding, you would run into issues where I want even 5 to be there. So ideally what you would do, you would make it 6, so that you would get the fifth, the last element as well. So in Rust, you can do a small shorthand syntax, which is basically equal to 5. So when you say 0 dot dot equal to 5, it means it's going to print the last element of the range as well. So 1 to 5. Yeah, so this is a simple for loop. And similarly, you have while loop. While loop is basically it keeps executing until the condition is met, where it will break, right? And this is the loop. So yeah, so this is a general overview of syntax or programming syntax in Rust and the regular functions that you'll be using. And yeah, and basically, yeah, this covers the intro of what a small recap. And I will now start off with explaining basic traits. So I think last time my co-host Varun had explained generics to you. I mean, he had written some part of code for generics and explained a balance function trait that he had used, right? So, starting off from that point, I am going to move on to explain what a trait is. So, what are traits in Rust? Basically, to give you a very simple explanation, I would just name trait is equal to abstract, an interface in object oriented programming. So in the OOPS concept, you write an interface, right? So if you were to write something in object oriented programming, say a class, so you just mention the class keyword and then you write a person and you write whatever computation you want, right? So similarly, in object-oriented programming, you also have something called as interface. I'm pretty sure all of you here are aware of. So interface is nothing but interface is you use the interface keyword and then write, say, human, and then you write the associated functions that this particular interface needs to have. Say, for example, function name. So all humans have a name, right? And this should return something. It's a string type. So probably most of you here are familiar with this kind of an interface. So basically what an interface is you do not define what is happening inside the function, right? You're only going to say, I need a function that is going to have a function called name, which returns the type string, right? Similarly, and if in class, and if I want to implement this interface on my class, what I would do is if person implements human. So this is just a pseudocode. I'm not referring to any particular programming language in general, but I'm just explaining OOPS concept and interface. So right, so you would say class person implements human, and here you would implement the function name. You would say name, which returns a type string, and say you're returning something, person1, right? So this is how this is a class. The difference between an interface and class is that you define functions and you also write the computation logic inside the functions. An interface is just an abstraction where you just name all the functions and what are the return types. So far, are you guys clear? Like, do you understand what an interface is, right? You could reply with an yes in the chat. So this is just
let's not open the chat. So let them use raising hand or thumbs up.
Yeah, sure. You could raise hands on Zoom. Yeah, you could use that also. Yeah, got it. Sure. Yeah, so basically whatever you understand, so I see many of you have raised your hands. So basically whatever you understand as an interface, this entire thing in Rust is called as a trait. So an interface is the equivalent to a trait in Rust. So in trait, you only define behaviors. Like for example, name is a behavior. You just define the behaviors, not the attributes itself. So that is basically a trait in Rust. So let us just look at a small code for the same. I just go ahead and remove these. So yeah, so I have already written a simple trait in Rust. So let us just have a look at that. So yeah, so I'll just split my screen. So as you can see here, I have defined a trait called summary, right? And I have written a function called summarize. The same way I have written a name. So I've the trait is called a summary, which is basically defining a behavior to summarize any of the data. And this keyword and self points to the original owner of the instance. So it's the owner of the instance. So if for example I have two structs in Rust, so struct is basically how you define like a key value pair in you define a class, right? I defined a class called person. It is similar to defining a class, but not, I wouldn't call it a class. It's a different concept called struct, but this is where you define the attributes. So I have a struct called news article, which has the attributes of headline, location, author, and content, and which are of type string, right? And similarly, I have another struct called tweet, which have these attributes: username, content, reply, and retweet. So here reply is a boolean and retweet is a boolean. So this is another data type. And now I want to implement this summary trait onto both of my structs. So this is my syntax. I would do implement summary. Summary is my name of the trait for my news article. And like I said, so here I define the behavior. Here I'm going to use the attributes from my instance to do the computation for returning a string which summarizes the entire news article here. So that's what I'm doing. So I'm using a format macro here. So format macro basically is it just gives you a line, right? And here I'm doing self.headline and self.author and self.location. So this syntax of curly brackets is a placeholder. So the first placeholder refers to the self.headline. So it is headlined by the author and in brackets the location of whatever it happened. So this summarizes the news article. Similarly, I have a tweet, and for the tweet I am implementing the summary trait, where I am just going to say give you the username and the content. So let us just see how this is going to work. So I have written this in a separate file. So you can see the folder structure here. I have traits in Rust, and inside my source folder, I have, so basically this is similar to just you do cargo new, like how it was shown in the previous. Yeah. So yeah, cargo new, you will get a new project structure that is say means with the source folder, the main folder, and your cargo.toml. So if you want to have a look at how cargo new is, so I'll just show you how it would be. So here I say so here I want to do a cargo new. So cargo, I want a new project of Rust that I can work with. So I say cargo new, and say you can name the project whatever it is. Say for example, it's a library for music. So cargo new music lib, right? And if I say -" lib, it refers to that I'm creating only a library. Means I do not define a runtime like main function, but yeah, you can either avoid the library or use library if you want to build the library. So it's the similar concept of libraries in any other language, Python, C++ or whatever. So if you see now it has been created. And so if you see here in my folder, I have a project that called music lib created, and under inside that I have a cargo.toml. So cargo.toml, here is where I define my the name of the package and all the dependencies that I'm going to use inside my package. So I think this is pretty familiar with you guys, because last year in the last session, Varun had clearly dived in depth of how you would call another crate and all that. So yeah, and then this is your source folder, which has the lib.rs for you to do any of the things, right? So I'll just remove the function. Yeah. And coming back to the main function here, I'm going to create a new instance of the tweet. So tweet, so here you can see right now it's already my compiler is already throwing an error saying cannot find the struct, variant, or union type tweet in the scope. So how do you import different files here? So I have written a basic trait. This is the file you're seeing to my right, and where I have implemented a summary trait, and tweet implements the summary trait, right? How do I import this in my project? I do this by using the mod keyword. So the mod keyword refers to that I'm going to use a module which is called basic trait, which is inside my root scope. So the root here always refers to the source directory. So inside my root, I have basic trait. So now you can see this is clear. It means you can see that it is source and basic trait.rs. But still, my error is still not gone. I still need to use the trait tweet, right? So for that, I would use the use keyword, use the basic trait, and here star just represent that whatever is there inside my basic trait folder. So I have news article, I have the summary trait, and I have the tweet. So whatever is there, I want to import it. So if I just do tweet, this error will go. And say if I do a star, it implements everything inside this folder. So that is my news article, the summary trait, and the tweet is imported into this main.rs. And here I have created a new instance of tweet by saying username is horsey books, content of whatever the description, and reply and retweet is a boolean, right? So now I want to use the behavior to summarize my tweet, right? So what I would call is I do tweet, let tweet and dot summarize. Tweet dot summarize. So I'll just showcase how this comes. Tweet dot summarize. So if you see when I do dot, there is content, reply, retweet, username, and summarize. So you can see the difference like in colors itself, right, on VS Code. And also you can see on my right hand, it means content is a variable. It's an attribute to my tweet. Reply is an attribute. Retweet is an attribute. Function, I mean, summarize here is a function because you can see it is using the Fn keyword. Fn keyword represents the function and username. So I call summarize, and now if I run my code, so I do cargo run directly. So you can see there is a println statement, basic trait in Rust, and one new tweet, course ebooks, of course, as you probably already know people. So yeah. So this is a simple implementation of a trait in Rust. So defining a struct and defining a trait and implementing the behavior. So implementing the trait for your struct. So are we clear? I mean, here until this point, you could raise hands. Am I good to move on with the next topic? Sure. Sure. So I'll just commit this code. Yeah, so it's just being pushed to GitHub. So yeah. So this is about basic traits in Rust, right? And now let us move on to something more advanced, because in Substrate, like moving on to the blockchain using the Substrate framework, this is the concept that you need to know in detail, so that you understand how Substrate is written and how you can code in Substrate. So that is the entire point of doing the Rust session, though you have come for learning Substrate and blockchain here, right? So you could relate. So the next session that is going to be taken by Varun is directly going to be on the Substrate framework, using the Substrate framework to work on the blockchain. But it implements traits and advanced traits very heavily, until and unless all of you are clear with what basic trait is, what is an advanced trait, how different functions are, you wouldn't be able to move on. Like it would be much harder, as it is, Rust is hard to pick up, right? But doing this, I mean, understanding this concept would be the first step to moving into Substrate framework development. Yeah. To start off, I'll just explain a very basic trait. So most of you must have heard of the iterator trait, like people who are coming from Java. So Java implements an iterator, there is C++. So iterator is nothing but a for loop, like it iterates over every element in the given object, right? So people who are familiar with an iterator, coming from whatever languages you are, please raise your hands. Yeah. So, got it. So yeah, that's good. Sure. So basically an iterator, so if I was going to say I have an array of numbers and I'm going to iterate it. So each of those numbers, it will be, so each index of the number is going to be iterated over, right? That is the functionality of an iterator. So to understand the iterator in like more depth, I would suggest you to use this link where it comes from the std library of Rust. It implements the iter module and the iter trait. So you can see it is a pub trait iterator, and it has a type called item. So if you see my previous code here, when I said a basic trait in Rust, you could have seen that I have not written anything that is similar to this type here, right? So that is what is the difference between a basic trait. I mean, one of the differences between a basic trait and an advanced trait. So in an advanced trait, what am I going to do is I can define an associated type. So what are associated types? Associated types are just placeholders that are added to your trait. So here my summary doesn't have an associated type. So if you say like a placeholder means I define at my initial trait definition saying I need a type called item, which can be anything. The type item can be anything. So in my interface, I'm going to say it implements a next function which returns my item. So this makes it much easier to write function. I mean, to implement traits which have very advanced functionalities that that brings out all the advantages of Rust. So similarly, if you see that is what a type here item means. It refers to an associated type. And you can see here the iterator implements, there are like about 70 methods that the iterator trait implements. So if you are going to write a module in Rust that implements the iterator, like I'm just saying, if a custom module you're going to write, you will have to implement all of these 70 methods, and that's how you go about it. So for the ease of explaining to you guys, I have written the same thing here, but I'm only going to write one function which is called the next. So you can see next is the first method of my iterator trait. For those who want to refer this document, I'll just leave it in the chat. How do I? Yeah, so this is this one. And for those who want to learn the basic traits and the other things, so this is the advanced traits from the book. So you could refer to this document as well. This is about what I'm going to teach you now, and what I have already taught you guys, that is the basic traits definition. So here's the link for the basic traits. So Rust book, I would suggest, like there are a lot of tutorials out there on YouTube and on Udemy or many of the coding platforms. But in Rust, one of the advantage is they have this Rust book that is open source and it's being updated constantly, and the documentation is beautiful in Rust. you have everything explained in detail, and you have all the methods and what function it takes. It's very simplified to the point, and it's very easy to read. So one of the skills being a Rust developer or being a Substrate developer is for you to be able to read the documentation, read as much as the documentation to solve your errors while coding Rust or Substrate, right? So that is one of the main things. So that is why I encourage all of you here to please have a look at basic traits once the section is over, and then move on to advanced traits, and the Substrate documentation will be shared by Varun, right? Yeah. So moving on, so this is a trait where I'm saying an associate type item. So and here I'm initializing a counter. So I am just creating a counter which is an empty struct, and I'm implementing the iterator trait for my counter, which is an associated type. And then I need to implement the function next here. So here what I'm doing here is so if you guys want me to code this for you, let me do it for you. So yeah, so basically it's a simple iterator trait. So I just define my iterator, and now I'm going to say pub struct say number, and I'm going to implement the trait iterator for number, right? And here I'm going to define my type. So type item is equal to number, can be anything. It can be I32, it can be a U32, it can be whatever it is, right? So for let us keep it as I64 here, and here I'm going to implement the next function. So the next function takes, so here there's a syntax called and mute self, right? So I'll come back to this. So it returns an option. So previously in one of the slides in Bootcamp 1, kindly go and refer to that. So option is an advanced enum in Rust, which has two types. It has none and some, right? It's an advanced enum. And I'm going to return the original type, that is my item itself. And how am I going to do that? I'm going to do sum of, I need an I64, so I can say 0. And like I said, advanced enums have two functions. So either it's sum or I can do none. So these are the two enums under an option. So none you return basically when you're going to not have any computation at the, I mean, any value at the end of the computation. And sum is basically you wrap the original value that you want to return inside the sum keyword, and you return the value. So I implement the trait here. So basically the next is implemented. So whenever a number is there, so a value of 0 would pop up, right? And now so let us just execute this piece of code to explain that whatever I've written is working now. So let's go to the main.rs. So here if you see so I am just going to execute the main.rs without calling any of these other functions that I'm going to explain. But you should be able to see advanced trace and Rust printed, right? So you can, okay, I'm on the wrong directory. So as I ran, so you can see there are a lot of warnings. We'll come to it in a bit, but these warnings are fine. It is intentional here. So you can see the thing has compiled successfully, and it says advanced trait and Rust is there, right? So this is a basic implementation of a an advanced trait which has an associated type. So basically, I'm going to say my item can be either of I64 or U32 or any of the primitive types. So here it need not necessarily be a number type. It can be an item, can be a string. So it can be a vector of strings. So it can be say item can be a string. So the next item in a vector can be the next string that is there in next index string in the same vector. So yeah, so I hope you guys get the concept here. So please raise your hands if you've understood what an advanced enum, advanced trait which has an associated type is and how you implement it. Got it. Sure. Okay, there were only few hands. I'm not sure if. Okay. Sure. I'll just move on now. So now the next concept is like, so whenever you're implementing an trait, there you could run into situations where, say, I have number, like I said I64, but in Rust, I say I want to implement a struct with the similar thing, but I want to have even another type. Say, I want to implement the same counter for type U16, right? So now when I uncomment this piece of code, right, this is going to throw an error saying that I have conflicting implementations. You can already see it on my screen. The compiler is crying, saying, firstly, it says type annotation is needed. So this is not the error here. The main error is over here. You can see I have already implemented iterator. I'm saying I'm going to implement another iterator, but the only change between these two implementations here are that is the type. Here it is a U32. Here it's a U128. And it's all, and it's saying, so just to read out the error, it's just conflicting in implementations of the trait, that is the iterator trait for the type counter, right? There is a first implementation, so it also points out there's a first implementation in line number 15. I have already implemented it, and in line number 24 I'm re-implementing it. So Rust will not let you do this behavior is not allowed. So if you were to implement a trait, you can only implement it for a single type. So now, I mean, probably the question would be like, if am I going to be restricted to just implement a trait for a single type each and every time I'm going to code in Rust? The answer is no. Though the compiler complains to you that you are trying to implement something that is already implemented and doesn't let you do it, there are other ways to do the same operation, right? So this is where the concept of generics pop into. So like you had seen in the previous session, hopefully you guys remember what was done in the previous session for generics. So this is a simple trait implementation where I'm calling the same iterator trait, whatever is there on top. So now let me just comment this entire section. So I'm not even going to declare this iterator type. So here, and I'm going to use generics to declare my iterator. So I say the trait iterator, and you can see in angle brackets, I'm writing the keyword as T, the key letter as T. So T here represents the generic, right? So T can be anything. So like, for example, it can be U16, it can be a U32, it can be any of the primitive types, it can be a string, it can be a Boolean, whatever it could be, right? And then I'm saying I need, so if you see here, I am not writing the keyword where, the syntax where I'm saying type item is equal to T, right? So when you're writing, so this is an advanced feature of advanced traits. When you're implementing generics on top of advanced trait, you do not need to define the item, because it is self-understood by the compiler, saying that the item here that is pointing to T is what it should use while at compilation. So this is already defined here, saying that my iterator is of type item T, where T can be anything. And I'm going to resend the same value, that is function next, to a mutable reference. So here, if you see, basically it's self here just points to the original parent owner of whoever calls the iterator, right? Whoever creates the instance of the counter. So self here is directly going to point to counter. So if I were to say let counter is equal to let new is equal to counter, so this is going to be my okay, let me do one thing. I'll do it in main.rs. So if you see here, so here, so this is my instance of counter. So when I do counter dot, so if I do new dot next, right? So you can see in the next, no, not found in the current scope. Yeah, it is not found in the current scope. The reason, because I have only written the trait, I have not implemented the trait yet, right? So I'll just uncomment this code for now. I'll explain it later. So this should be gone. So right. So now you see the error is gone because I have implemented a main. The next function here. So here, what it means. So next takes a parameter and mute self. Your self directly points to the counter. So this is what I want to explain. So did everybody understand the self keyword and where it points to? Like, please raise your hands again. Got it. Sure. So yeah, moving on. So here, this is a generic type T. I have my associated type is a type T, which is generic, and I'm implementing. So here, if you see the syntax change, so I'm implementing an iterator. Here, whatever is an angle bracket, this is my type item. My item here is going to be U32 for counter. So right, so here I can return the next function, which is returning an option, which is sum of 0, which is a U32. So basically, the type of my counter variable that returns the next, the returns the value for next is going to be of type U32. Similarly, now the previous problem, so I want to implement U16 as well. I want a U16 value for my trait. So to do that, I can solve it by generics. So here I've already said T can be anything, right? So here I can implement iterator with a U16 type for a counter and return my option as U16. The main difference or the main takeaway that all of you need to understand here is I have implemented a generic type T, which can be anything. And my trait, my advanced trait does not need to depend on a custom on any type that you're going to define. So this is where Rust shines. You could see the compiler is complaining to you when you're trying to do a simple implementation where you want another instance, but you want it of type U16. So the compiler is not going to let you do that. But on the other hand, it gives you another way of solving the same solution, right? Similarly, I can implement the iterator for multiple types, say a U128, a U16, and stuff like that. Right. So how do I know my return type is going to be of type U32? So let x is equal to counter.new and say now I'm going to write that. Sorry. Yeah. So here now say I want my next function called, but next function is of type U32, right? So it can be of anything. So here, if I were to say my x is going to be x. So let y is of type U32 is equal to x dot next dot unwrap. So unwrap is basically a keyword. It's a small syntax to so because you can see in this particular thing I'm doing sum, right? So when you unwrap, the sum wrapper is gone and you get whatever is there inside the inside the wrapper, the main value. So when I do this, so I would get it here. So you can already see my compiler is throwing that x is not a mutable reference because here I have definitely returning that I am doing and mute of self, right? I need to pass a reference of self which is mutable. Means mutable here is a keyword that says I can mutate or change the value of my original owner's instance or its attributes, right? So just to make this work, I would just add mute, and you can see x is of type U32, and it works, it compiles, right? So if I make it U128, you see now it's going to throw me an error which says the trait bound. So this is what I want you guys to particularly notice here. So the trait bound iterator counter iterator of type U128 is not satisfied. Means I have not written an iterator for the U128. That is why my compiler is complaining. So, and you can also see that it is showing you what are the implementations that I have done. I have implemented my iterator trait for my counter for a U16 value and for U32 value. This is one of the most frequent errors that you would be facing in Substrate when you're like starting to code, where it would compiler will start complaining where you do not have this type implemented. And to understand the error, this is what it means. It means a generic type has been implemented for an associated type being as T or any of the generic type, and you have implemented only a certain primitive values for that. There are also concepts of custom values, but we are not going to reach there today. And yeah, so basically you see the error. So I'm to fix this, the only way I can fix this, so I want a U128 type is me implementing the iterator trait using a U128 type. So now you see, now my compiler is like happy with me implementing any number of primitive types that I want for my iterator trait. Previously it was complaining just for a single change of value. Now it's fine. It's okay for it to let me implement anything. So I implement a U128 and you can see a U128, the error is gone, right? So basically, this is the concept of using generics to solve a problem of implementing multiple types. So you need not, though Rust is a statically typed language, means you're going to define every single type that you're ever going to use in the program. You could also compute functions, not necessarily always saying that you have that type has to be defined. So, and a simple example of this, of that is this. So people, are you clear here? Like, so far, is it good enough? Can I proceed?
Loki, audience request, you need to slow down a bit, it seems.
Okay, I need to slow down a bit. Got it, sure.
We can.
Yeah. So yeah, so this is basically about what I had trying to showcase the error for you guys. So the same, I will just quickly comment the code. Yeah. So moving on. So the next bit that I'm going to cover is going to be generic type parameters. So here what I'm going to cover is going to be generic default type parameters for my generics. So to begin with, yeah, so to begin with, there's the concept. So you have understood an advanced trade, what an associated item is, and how you would solve implementing advanced trades for different types by generics. So at this point, I want to take it to the next level where you have generics implemented, and I also want to add some sort of operators. So if you see my line number 1 here, so I'm using use std. Std is my standard library, and ops is a library for operators. So you can see overloadable operators. So this is a library written with a lot of not just add. There are a lot of overloadable operators. There's multiplication, division. There are custom operators. So now I want to add an operator for my trait, my advanced generic trait. Right, so that is what we are going to do it right now. Got it? Yeah. And yeah, could you guys just give me 1 minute? I'm going to be on mute for 10 seconds. Meanwhile, please type any of your questions on chat.
All of you who have raised your hands, if you can DM Varun or Lokesh. In the meanwhile, guys, those of you who are developers definitely and have not joined our Discord channel yet, do find our Discord channel by filling in the form that we have shared a link for in the chat box, and we'll keep it more interactive even after this session. Yeah, that's your link again for the Discord channel, and do fill in. Meanwhile, guys, let's just run a quick poll before Lokesh is back. So let's get to know you all a little better about how many years of experience do you have as a developer? Are you still a student? Do you have less than a year, 1 to 2 years, more than 2 years? Just let us know so that we understand if this curriculum is working out for you. And yeah, great. Thanks for the responses that are coming in. We see most of you are still students. That's about 80% still. Most of you less than a year again, 16%, 1 to 2 years, that's 5% of you. And about 4% of you are more than 2 years of developer experience. So great, guys. This is a great combination we have out here. So hope all of you are learning a tad bit. And also feel free to tell us what exactly you would like to learn specifically in the coming times. So that's what we mean by keep it interactive. Tell us what you want to learn. Tell us what would help you grow better or what your plans are. And we can see how we can help with educating you, or maybe even giving you opportunities or exposing you to opportunities that you can actually have hands-on experience with. So just keep talking and keep interacting with all of us. With internships, again, like while as a community, who is this? Tarun, I'm answering your question about how to get internships. Soon, like while this is our first attempt at training all of you, we will be opening up plans wherein all of you get project opportunities too. So that's something we've planned for after at least this first boot camp that ends next month. But otherwise, there are a lot of portals that help with this kind of opportunity, and we keep sharing such resources on our Discord and Telegram and WhatsApp channel. So join in again into all the channels, and I think we've already shared a couple of portals that help out with internships and some beginner job opportunities in this sector, right? Okay, we can end the poll now. That's 81% still students. 15% at less than a year, 1 to 2 years is at 6%, and more than 2 years is 5%. Thanks, guys. Thanks for being so responsive. And yeah, I think we can continue. Lokesh, are we back? Do you want to resume?
Yes, I'm back. Yeah, we can continue.
Sure. Thanks.
Sure. So like I said, so we are going to try to implement an add operator. It's a simple function. Add lets you add two numbers or two basically two instances of any declared type. So that is the difference. So you could regularly add two numbers, 1 plus 1, right? But here the add operator lets you implement let you add two different types, right? So what do you mean by add two different custom types or declared types is what we're going to see here right now. So it is simple. So the same way how you add a trait for a single struct. So I have a struct called a point, right? I have a struct called point, which is going to tell me that so beginning, I'm going to comment this line, and I have a struct called point, and I'm just going to say implement add for the point. And here, if you see that add is also a trait, though it's an operator, which takes a type, right? So type output is going to be of type point. So this is where you define saying that I can add two custom defined types as well. So this is the logic behind that. So yeah. And so here type output is going to be of point, and then you implement the add function. So the add function for add, where it takes up a self. So previously, like I have explained, self points to the instance that is calling the function add, right? So here in this particular case, my function self is going to point, is point, right? And it also takes another parameter. The other parameter is a point. So, and then I'm going to return a point. So basically we are, and what am I returning here? I'm returning a new struct, which is point, which is X and Y. X is of I32 and Y is I32. I'm going to add the original instance. So the instance of my first point, the value of X, plus the instance of my another point, like another parameter that I'm passing, and I'm going to add it, and the X will be the new value of it. I'm going to return a new point which is having the addition of those two. Similarly, it's going to be for Y, right? So now let us see how this is going to work. So if you see my assert statement, so this is some simpler way, like when I say an add operator. So this is what I meant by it lets you add two different types or custom types that you have defined, right? So if you see the syntax in line number 20, I'm doing point X as 1, Y as 0, plus point X as 2 and Y as 3, right? So when I do point plus point, ideally in any language, when you do this, the compiler is not going to let you do this at all, right? It's going to complain. You cannot add two different custom types. But since we've implemented the add operator, so why am I calling this specifically as an operator? Because it is an operator. I'll come back to explain why specifically it's an operator, but then this is special kind of a trait. an advanced trait, right? Because it gives you all your mathematic operations, right? That is the main difference here. And if you see, I'm asserting that the 0.10 plus 0.23 should give me a new point. That is, I add a function, so that is point plus point, and it should return a new point which is of value x is 3, y is 3. So 1 plus 2 3, 0 plus 3 is 3, right? So if I were to run this code right now, so you can see my compiler is already complaining, saying that generic type parameters point as a binary operation equal to cannot be applied to generic type parameter, right? This is first error, and I have another error that says doesn't implement the debug, right? So the reason, this was intentional. So I wanted to show you guys that you have other super traits. So these are called as super traits. So basically debug lets you debug as a trait. So that lets you print out some sort of some sort of data onto your debugging console, right? And it implements some other debug traits as well, the function debug. Okay. And similarly, you have an equal to operation. So I cannot equate some two structs, defined structs, until and unless I have implemented a partial EQ trait. Partial EQ is another trait which lets you compare between two different custom types, right? So that is what for a struct. So that is where in line number 12. So I have the syntax where I do hashtag. Hashtag stands for attribute macros, but let us not get in depth into that. All you need to know is you need to call a derive function. Derive basically lets you call all the super traits that you want to implement for my struct. So my struct not only implements the add operator, it also implements super traits of debug, copy, clone, and partial EQ. Partial EQ, if you read the documentation here, you can see it lets you compare two different values, right? You can do non-equal to and you can do equal to. And similarly, a debug trait. A debug trait basically it implements the function debug. And then you have the copy and clone. So copy is basically it lets you call a moved value. Moved value is basically like similarly struct is foo, let x is foo, now y is foo, means now the value of x is no longer there in x, it is there in my y. So that is basically the copy trait. So it lets you implement a it lets you use the x and it copies the same x value to y, right? And yeah. And moving on, so this is a clone trait. Clone trait basically lets you this is it's tricky here, but both of you, all of you might have a lot of questions here, but this is something I'm going to leave for you guys to discover. It must be pretty simple for you guys to discover what's the difference between copy and clone, and I would suggest all of you to refer the documentation. So this way, we could also assess how good you would be at reading a documentation, right? So, and moving on, partial EQ, as I explained, it lets you the equal trait. So now if I do a cargo run, you can see that I no longer have the errors that I had before. So that is what the derive function does. So you call a macro and you say derive, you call the derive function along with the super traits that you want to implement for your struct, right? And now if you see it compiled because my assertion has successfully compiled, saying that yes, I am getting a point which is of x, 3, and 4. So if you want to see the assertion failure, let me say I make it at 7. Now you see this assertion will fail. So, and if you see the exact message here, it says that the thread main panicked at assertion failed, left equal to right? So it says my LHS is not equal to RHS. It says left, there's a point 3 and 3. 3 and 3 is the point, that actual result. But I am saying that it is equal. The expected value is 7 and 3. It's saying no, I don't have that thing, and the assertion fails, right? So for that, I just do the 3 and it's going to work. But the real takeaway here is how I use an add operator, an operator to apply to my advanced traits, right? So that is basically about using operators. And moving on, I just want to explain the same operator function, but So the same add trade. So like I said previously, I have only add like the point, right? So I can add two different, like I can add the struct points. I can add any number of points. Like I can keep adding the struct points, but can I add a point and another struct? So that is a question here. So that is what I'm going to showcase here. So I have another struct, which is millimeters. And then I have meters. So can you add millimeters plus meters in regular life? Yes, because you know the computation of how many zeros you need to add to convert millimeters to meters, right? Or number of decimals, right? And you would compute it. But I want to tell my Rust program also the same. I want to implement that functionality that even though I am giving you a millimeter value, even though I'm giving you a meter value, I want the millimeters in return. So that is what we are going to look at. And how are we achieving it? Like I previously showed in the generic implementation of iterator, I'm going to add generics to my add function. So add operator. So here there's a very brilliant question. How come I'm adding a generic to an add, right? I'll explain this right after I showcase what this function is, right? So here line number 35, I've written, I'm implementing add with my generic here is meters. So meters is a struct which takes a tuple. So basically you define a tuple and it's of type U32, right? And it can be of any whatever meter. So basically you're saying 1 meter or 2 meter or whatever it is. And another struct is a millimeters, where again it's a difference of, defined with a tuple of unit value, which is again a U32. And now I'm saying my type here, type here, like the generic type is going to be meters, and but my type output that I'm expecting for my add operator to return is of type millimeters. So even though I add millimeters plus meters, I should get an output of millimeters. I want an output in millimeters. This is basically what I'm trying to do here. And as normal, I do the function add, and then I pass a self and the other parameter basically. So the other parameter takes the meters. So I'm passing a meter and it should return a millimeter value, right? So millimeter. So here is where you would ideally do the regular conversion of meter and number of decimals and all that, right? But you don't want to do this every time in your code, where you just want to do line number 13 and every time you're going to convert meter value to return millimeter, right? You would write a small helper function for that. But then this is a better way of using generics and advanced traits to achieve the same. Because once I've done this, even though I add, so if you see line number 25, I just need to add millimeters plus meters. It's going to work for me. So this is the beauty of advanced traits. And if you see, here is a computation. I'm going to return a millimeter, which is self.0. So self is pointing to my millimeters here, right? This is clear, right? The self keyword is millimeters. And then self.0. Self.0, because it is a tuple. So in Rust, the way you access a value in a tuple is by dot the index of a tuple. So it can be 0. If it was going to be comma another U32, is going to, it'll be self.1. Got it? So this is a syntax of how you access a tuple. What is a tuple? Tuple is an immutable data structure, which is basically used for writing some short data. You just want 2 parameters. You don't want to use like an array, or you don't want to use a map. So that is when you would be using a tuple. And this is immutable. You can't change the value inside a tuple once declared. So self.0. So self.0 would be whatever value this U32 is to my millimeter, and then other is my meter struct. So meters.0 would point to this value in line number 33 into 1000, because the conversion parameter is that, right? So now I would return this value, which would return my value in millimeters. So let us see how this is working now. So if you see the same syntax, ideally, if this was not implemented, right, it's going to compile. My compiler is going to start throwing errors. So for you guys to see the error clearly, so let me print it out here. So you can see it throws an error saying cannot add generic type parameters meters to a generic type parameter millimeter. So this is not possible at all, right? You cannot do 2 different types unless you have defined it, right? So that is where adding a generic with an add operator comes into picture. So now I can run the same code. And to show you guys, I'm giving a value of millimeter that is 1000 millimeters and a meter of 1. So when you're 1000 millimeters plus 1 meter should return you 2000 millimeters, right? So let us look at the error condition first and say I'm returning 4. And you can see it's already throwing an error saying my left, it compiled according based on this equation value in line number 39. It's saying it's returning a value of millimeters, which is 2000. That is correct. And it is here what I'm trying to say is equal to 4000 is wrong. So the session failed. So obviously, yeah, it's going to be 2. And I solved it. So now you see the compilation was successful, right? So this is about using generics in add. So now just to give you a small insight of why an operator here add is so unique that I can write, implement a generic for my add. So the answer lies in the implementation of add in the standard library. So basically the understand the ops library, right? The ops stands for the operators. So you can see that. So this is basically the implementation. So they have implemented a trait add, which takes a generic type. So initially it is having a generic type. And the difference here is that, so previously if I, in my iterator, so let me just open my iterator and show you guys that, so here, whenever I had a custom generic type T added for my iterator, I have always provided whatever type it is here while implementation. So implemented iterator with U32. But if you see in add here, I have not provided my type, right? I have not provided any type here saying my add is going to be of type I32, right? I have not done that, but still the compiler ran and the code worked. The reason being, it's very simple. RHS is the type, the generic type, which is equal to self, means this equal to self is a default generic type. So it going back to the initial point where I had told you that you can write a for loop. So for x in 0 to 5, but I want to include my last argument as well. I would implement it as equal to, right? And then I do whatever computation I want with it. So this is a similar syntax where so here I'm including the last operator. That is the main meaning. And on the other hand, here what I'm doing is I'm saying my RHS type is of default self. So even though in line number 18, I have not defined any of the generic type, it is still going to work because it is the default type parameter. The default generic type parameter for RHS is going to be self. So what does self point to here? I've explained it to you. Self points to the point struct, right? So that is the reason it worked. And if you see the function add, it's pretty simple. You just pass the self, you pass the RHS that you want, and then you return the output, the type output. So this is what you call, so this particular line number 6, when you do RHS equal to self, is the implementation of a default concrete type for your generic advanced trait. I'll just reiterate what I told you. It is the syntax to write a default concrete type for an advanced trait, advanced generic trait. So is this clear with all of you? Like so far, so this is the end of this module where I'm explaining operators and concrete default types for generic operators and stuff. So yeah, if you guys are good with this, please raise your hand just to show that you guys are understood, and I can move on to the next section. So I mean, a very few of you have raised hands. I'm assuming was it I mean, why is there very few hands? Was it too complicated for you guys to understand, or what is it? You could leave your messages on the Discord group of why do you feel there. I mean those of you who have not raised your hands, why do you feel that you've not been able to grasp what was there? Sure. Sure, Ananya, like if you could just do share any of the comments that are posted. So if there are any questions on why they didn't understand, we could address it.
Sure. As of now, there's nothing. So
Okay.
I think we'll wait for people to tell us in detail what's on their mind.
Sure.
But I think we've been having a consistent 7 to 8 hands minimum raising. So I think we'll take that as a good number to move on. Maybe.
Yeah, got it. Sure. So, so this is about generic types and concrete default generic types. So yeah. Now moving on. So the next topic that I want to cover is basically my methods with the same name. So this is a similar problem that each developer in his career is going to implement, and he's going to face an error, be it any language. So I'm specifically talking about low level languages, because low level languages is not going to let you. So if it was Python or JavaScript, it's all right for you to call the same function for a same instance. So like, for example, I have a human instance, I'm writing fly, and I have a pilot instance, which pilot is my trait. So it would let you call it, but however here it wouldn't be the case. In low level programming language, that is not the case. For example, in Java is also going to cry to you saying that I cannot do this, right? So let's see how we approach this problem, right? So I have a trait called pilot, which implements the same function fly, and it takes a reference to self, right? And here is it stands saying that it's a reference to self. And I have another trait called wizard, which also implements a fly function, which is a reference to self, which takes a reference to self, right? So now, you already have a complication here, right? I have two traits which have the same function called fly. How am I going to use it in my code? Which trait am I going to implement? For example, I have a human struct which with no particular value. The reason I'm doing this is because just for explaining the concept here, right? So I implement the human struct. So this implement human without any functions just means you're implementing some functions for the struct, like whatever competence. So like, for example, in classes, you would implement a dog class where dog you would do sound, which returns bark, right? So it's similar to that. It's specific and unique only to dog, right? It's not there in other classes. So that is these are basically in Rust. You would also call this as helper functions in Substrate, and these are also callable functions for your struct, right? So my human struct also implements the fly function. So now that is a weird thing. So other than wizard and pilot, my human struct also implements a helper function which calls fly, which when I call fly, it prints waving arms furiously, right? And so now how are we going to tackle this problem? And I am also going to implement the pilot for human and wizard for human, which means now my human struct has 3 fly methods that I can call, right? So how am I going to show that to you? So say I create a instance of let person is equal to human, and then I will do person.fly. So but before I do this, I do not want to showcase this directly. So let me show what are the differences. You can already see that there are 3 fly functions. It's weird, right? It shouldn't be the case where you're going to have 3 different fly functions, right? You wouldn't know which fly to choose from, right? Because one is a helper function to human, the other is a trait function of pilot trait, and the other is a trait function of the wizard trait, right? You don't know. So the moment I call fly, this compiler is going to start crying, saying that I have cannot find fly in the scope, right? So so the reason why it cannot find scope. So here, so let me showcase this error. It says that multiple fly found, right? So one of the errors that you can immediately find is that there are multiple fly functions found. So the compiler doesn't know which fly function to call, what am I going to call? It's not sure. And second, it's saying the fly function is not found. The scope is not found, right? That the reason for that is because here fly, the one that I had written in line number 20, is a private value. It is not exposed for my another file to view it or access it, right? To solve that issue, you just add pub keyword. Pub is a stands for public. Generic here, the point struct, you see pub x, right? Pub x means I'm going to expose this x variable attribute to any other file that is calling it. So that solves the thing issue. So now my compiler is fine. There's no errors here at all. And now let us just see what is the compiler going to choose. So any of you, like, I want you guys to leave a message or like some sort of thing on. So if so you guys could react with a reaction. So if you think there are 3 fly functions, when this code is going to compile, which of the 5 fly functions is it going to call? So if it's going to be the first fly function, please raise hand. And if it's going to be the second fly function, please do a smiley. And if it is a third fly function, do a celebration emoji. Okay. Okay, so most of you are saying it is going to call my first function, right? So let us see what the compiler is thinking. So when I do cargo, so yeah, it has ready-made called this thing waving arms furiously, which is a helper function to human, right? Correct. So this is what happens. So like it ignores the pilot and the wizard trait implementations fly, and it takes the helper function, right? Now the question that would pop up here is, okay, I got it. So by default, I will get it that I take my helper function. So when are the cases where I want to implement, use the fly method from my pilot trait? I want to use a trait function, right, for computation. How can I do that, right? So that is what, so that is a syntax where, so you can still do that. So Rust is going to let you do that. So how are we going to do that is by this syntax. So you can call a method for multiple implementations by calling its trait. So I have imported the trait, right? So each of my trait is a public trait. So how do I know that I'm doing that is here. So when you see I have methods with the same name, and if I remove the star, you can see, I can see the trait pilot and wizard. I can import it, right? So I'll go back to the star syntax just for ease of use. And now the compiler is throwing saying that I can call fly. So it's taking the pub trait pilot. I can call fly, which calls the pilot trait, but it's saying it can't find a person value. It can't find the reference to a person. So that's because here, when I've implemented fly, I have taken a self-reference, a reference to self. So I also need to instantiate my human struct, and it will be fine. So now if I were to print line number 31, 35, 36, if I were to call these functions fly, you would see 3 different, you would see that I can call all of these fly functions that I've implemented. So let us have a quick look at that. So you can see, first thing, it came waving arms furiously, which is from the helper function. The second implementation is the fly from my pilot trait. That is how I use the syntax, by calling the trait, and I can call the function that the trait uses. The only difference here in the syntax wise is, here I'm doing person.fly, right? Ideally, this is how you would call any of the helper functions or any of the functions. Previously, even on iterator, I had shown you, I do x.next, right? That's one. But in this particular case, where I have the same name the same name of a function implemented for a lot of traits, then I need to use the syntax. This is the only syntax that is allowed. So I do pilot.fly and wizard.fly, and my third is up. So it is just up. So yeah, so this is about how I would implement something with the same name, a trait with different traits with the same name, doing some computation, and how I would call it in the code, right? And another quick point that I wanted to point out is, so in Substrate, you're going to find the syntax a lot, the one that I'm going to show you. So that is the main reason why I even brought it here to showcase it. So similarly, there is a concept of associated functions. Previously, I told you advanced traits have associated types. So now when you implement any of the trait, you can also have associated functions. So what is the difference between an associated function and a function that takes a self? A regular function, right? So the syntax is this. An associated function doesn't take any function reference. It just takes parameters. I can pass any parameter here, x is I32 or whatever it is, but it doesn't take the self. It doesn't take the self reference. Means you don't necessarily need to depend on the instance that you have created. For example, here I have created let person is equal to new. So an associated function is not dependent on it. So now let us change all of my traits to use associated function. So I'm going to comment this. I'm going to enable associated function. And similarly, I'm going to, when I'm implementing, I can't use this. So see, my compiler is already crying here, like, I mean, throwing errors, saying that method fly has an and self declaration. So reference to a self in the implement, but it is not in the trait. In the trait, it is not there, because in my trait, I don't have a function reference. I mean, I don't have a instant reference. I only have an associated function. So similarly, we will have to do it. So I just comment it and I implement an associated function. Similarly for my wizard trait, and also I want to make my human function also associated function. So you can see the compiler now is saying associated function fly is never used. So I want to change it, and I want to give my associated function syntax here. And how do I, so now the point is, you already know Rust is going to let you call these different functions in different methods. But now if I were to create a person, so I mean, I don't need to create a person. So there, the handicap of creating an instance for the particular trait function is not required, because these are associated functions. So to do so, the way you call that is this way. So you would call the fly, the human is a struct, right? I can directly call human struct and then call fly, which is going to let me compile it. So you see, when I compile it, it's throwing waving arms furiously. I have not instantiated human, the person, let person is equal to human. I have not done this at all, right? And the other, now how would I call human, I mean, the pilot and wizard? So this syntax won't work because I need to pass the reference for the instance. So this is the syntax that this is a syntax that you're most heavily going to find in the Substrate framework, where you would call the struct human as. So the as keyword points to the trait that you want this human to be of. So this human is a pilot, this human is a wizard, and you can see that this is custom syntax which is written inside angular brackets. So angular brackets and human as pilot, and then you call the fly function. So similarly wizard, and now if I compile this code, you can see all my three print statements are working. And this is how associated functions are used. So a trait can have a referenced function as well as an associated function. So you can have both the types in while defining a trait, right? And that concludes what I wanted to show you guys about associated functions and what are associated functions, how you would call these different types, and whatever it is. So let us just take a small 2-minute session to check how many of you guys are following so far. Is it a good enough pace, and is it clear whatever I have showcased until now? You could raise hands basically. Got it. Sure. And yeah, so the next few things that I wanted to showcase, but since we are already like went ahead of time, I'll just give you a brief of what I was going to showcase is something called as super traits. Super traits is nothing but a trait that implements another trait. So you see, I have written a trait called outline, and I have also saying that it implements another trait called display. Yeah, so it also implements another trait called display. So let us move on to this. Probably this is also an important concept for the Substrate thing. So here what I'm trying to do is, it's just a printable trait. I'm just doing a function called outline print, where I'm just printing some things which basically returns an output like this, right? And the only difference here is that I am using this semicolon in my trait declaration itself, and also adding another trait called Fmt Display. So display comes from the standard library, and Fmt is just it stands for the format. Display basically is a trait that enables the function display, which lets you print stuff onto the debugging console or at any given runtime where the program is executed. Right? It's a very simple thing. It's just a trait for printing stuff. to be simple, right? So I want my outline print to implement a display trait. So that is what I'm trying to do. So now let us just see that I mean, the main takeaway here is Rust lets you implement different traits on top of a trait. So it's like an interface on interface uses other interfaces. So that is what I'm trying to point to here, right? And it's similar. So these are called as super traits. So anything that is defined after the colon and any other this one. So I can also do the debug trait the same way that I showed you. So right, so I can write this, I can keep adding it, and I can keep going. So I can add multiple traits as and when I want in my trait definition itself, right? So this will help in a way where you need not, so the instance or the function or the struct that you're calling need not necessarily define the trait that it additionally wants to implement. I am talking about the self. So here self is a second point. I don't need to define something additional trait. So at the trait definition itself, I'm saying my function needs to have this display trait. It needs to have an associated type and a super trait implemented for it. If you are going to call it, my second point struct is going to call the function outline print, it should also have the display trait. So coming to that point, just hold your thought there. I will explain it in the next few minutes. But yeah, let us just see the execution of a super trait. So what I have done is a shorthand. So basically I'm initializing second point struct, and I've done x is i32 and y is i32, and I'm calling the function outline print. So I'm just, so you can see that here I have not implemented the function outline print here, right? Because this need not always I mean, here I'm not trying to showcase the functionality of traits, which I've already shown the past few hours that we have having this session. So I'm not going to do that. So, but here the point is, so if I were to run here, you can see it's throwing an error, and error is specifically saying that super trait second point doesn't implement the function standard FMT display, right? Cannot be formatted with the default formatter. Rust has a default formatter, but it cannot be done so. That is what Rust is complaining, saying that the display trait is not implemented. Why is it specifically saying I mean, this is not, I mean, it's just at compile time, right? Why is it saying that? Because I have defined a super trait called display. So I need to fix this. To fix this, I need to implement the display trait, and so implement display trait for my second point. And my second point, it takes the function FMT. It's a formatter. It takes a reference to my original formatter. So you need not worry about all this, like this particular piece of code. This is not what I'm trying to focus on. What I'm trying to focus on is super traits. So all you need to do is whatever super trait it is. And you already, I mean, by now, all of you have seen how you implement a trait for your instance or for your struct, right? So it's the same way. So you just read the documentation on how you do it, and you should be able to implement it right away, right? And you just write out. Write function is just a macro that writes out to the display trait. So to give you a brief example, write is basically a std out. So in Java, you have a feature where you print on the runtime, given runtime you're writing, right? It's the same functionality here. So yeah. So this is where I just wanted to showcase that you can implement super traits on a trait. So having multiple traits on a trait, and all you have to do is implement the super trait for the instance that you're creating, other than the actual trait that you're implementing. So once you do this, I can call outline print, and the compiler is going to be fine, and it's going to return the data. So whatever I have printed here, right? So whatever I'm doing here. So this is a small brief of what a super trait, I mean, super traits are, and how you use super traits, and facing, I mean, facing the errors that the compiler is going to throw, and how we would solve it. All you have to do is just implement the super trait for the instance that you are doing it. And if you are going to write custom traits, just you can always follow this, right? So that is about super trait. And so we have reached the last section of what I wanted to showcase for today. Which is just a simple wrapper. So for example, I do not want to dive deep into this, but I just want to give you a small explanation of what basically this is, right? And so these are super traits. So I mean, this is a new patterns. So this is a concept of new type patterns. So here, I have shared the link to Rust book, right? So there is a rule that is defined called the Orphan Rule, which states that we can implement a trait as long as the trait of the pattern is defined within our crate, which means basically this my entire project. So forget about this. So this entire thing is a single project. If I have the dependent function that trait implement, coming from this crate, I am fine. I can implement it. But there are errors. There are such cases where people mostly write custom traits, and that is coming from a library. It's not within my scope or whatever it is, right? In that situation is where you would use the new pattern type. So the new pattern type, basically, let me just read this out because it's a better definition rather than me explaining it. So the new type pattern allows us to get around this restriction by creating a type struct. It's a tuple. So tuple, right? Creating a tuple struct with one field, which is going to be the type we are wrapping. So this is the wrapper is local to our crate. So this wrapper is local to our crate. So we can implement a new trait for it. Right? So a vector by default. So what I'm trying to showcase here is that a vector by default, if I want to display it, I need to write a syntax of formatting my vector. So let me just show you what it is. So let me say let an array. So vector is basically an array. So I write an array of say 0, 1, 2, 3, right? So I write an array. I want to print this particular array. Okay. So you can immediately see that the compiler is throwing an error saying that the standard vector integer does not implement the display trait. I cannot implement. I just can't print all the contents of a vector like this. Like I'm pretty sure most of you might have faced this situation where you have an array, and especially people who are new to programming, those who have started programming in their initial days, you just write an array, you want to print all the contents of an array, but the language is not letting you. Those who have faced this situation, like, please raise your hands. It's a very funny situation. Yeah, exactly. So yeah, it's a very funny problem, right? So we have the same issue here, and in Rust it also requires you to implement the display trait to do an array, right? And every time I want to do this, I need to, so in Rust there's a small shortcut that I can implement. So see, if right now the code won't compile, it's going to throw an error saying that the display trait is not implemented. And how do I fix this? I just write a formatter. So this is a debug formatter by default. Whenever I write a colon and then I write a question mark, it means that it implements a debug trait where I can print the display, right? I can display what are the contents are. So if I were to run this, you can see I get everything 1, 2, 4, right? And this hash is basically pretty fine. Like it's a pretty formatter. Pretty formatter is used for structs, which say you defined a struct, you want it in a key value pair in every next line. You don't want it in one long line that is like continuously you need to scrolling. Yeah, that is basically it. So yeah, so this is a small short, and you can see the pretty formatter now gave all of my values of an array in each next line, following line, right? 1 to 4. But this is a shorthand syntax. So, but this is a small display trait. Like you're not going to be worried about doing so. But what if you're doing some custom traits of your own, which implements a trait that you need to implement that trait? Else the compiler is not going to let you call a function or compute anything to it. For example, a len function, which says a vector.len. You're not, the compiler is not letting you do so. So that is where the new pattern type concept comes in. So it's a very simple thing. You just write a wrapper, a struct wrapper. You define a unit tuple of the thing that you want to display, or not display, you want to use, or you want to use that trait for the custom type. So it's a custom type here. So whatever you see here, I'm just referring it as a custom type. And then you implement the display for wrapper and you write the function format, right? And then, and the write function, like I explained, it's how you want to showcase it in my console. right? So now if I do wrapper is an instance of my wrapper struct, and I do a vector of strings. So I have a vector of string hello, and I have the world. So I have 2 words inside my vector, right? And now if I were to print it, the compiler is not going to throw any error. So it's going to smoothly run through this, and it's going to say hello world. Yeah. So this is concept of new pattern type. So this is very useful, especially when you're coding something where you do not have the trait. Say I'm calling a library, another library from trace.io, and that needs another trait to be implemented, but that is not coming from that library. I don't have it in my local scope as well, so I'm not able to use any of the functions that it requires, right? So this is a small workaround of how you can solve the problem, right? So with this, I think I'm done with my session. So this is mostly about advanced traits and all the things that you want to do. Basic traits and advanced traits and the errors that you would probably face in coding. And most of these things that I show you with Substrate, you're going to face a lot of these. And the syntaxes that I've shown you is going to be very familiar once the Substrate framework starts. And yeah, this is the end of my presentation. And those of you have questions, we are Ananya, is it all right to take up some questions, or we could move on to the next session?
Yes, we can take up questions now. In fact, there's a development. The next session we have planned for you can go up to 2 hours more. So what we have decided to do is wind up today and have a continuation or a part 2 of today's session next Saturday. That's the 29th at 3 p.m. again. Hope that's fine with the community. Can you all give us a raise of hand if you're fine with that? Great. So there's a link we are sharing in the chat box right now. If you can just fill in your details there again, we'll send you a fresh link to join in next Saturday at 3 p.m. and we'll have a second session then, right? Thanks, Lokesh. I don't think we have any questions. If we have any questions, if you can DM or send your questions out in the chat box, that would be great.
Yeah, sure. So, and also for those of you who want to refer to the code that is shared, it's available in the chat box. Yeah.
Great. Otherwise, guys, you can always join in our Discord channel and still shoot in your questions. You have all the time, and we shall get back to you with that. And yeah, thanks, Lokesh. This was truly required for our developer buddies out here to stay on track. And yeah, so we'll see you all on 29th. But before that, a couple of things. Thanks, guys. Thanks for this response. Okay, so let's do a quick fun round of a quiz, your final quiz question for today. So if you can showcase that on the screen, please. Right. Okay, so your question for the end of the event is which of these two is actually the light version and the inexpensive version? A, copy, B, clone, C, both are equally inexpensive. So all you have to do is tweet your answer and tag us at #.friday. Sorry, #Substrate Saturday. I'm really sorry for that. With #Substrate Saturday, you have the details of that in chat again. So that's which of these two is actually the light version and inexpensive? That's A, copy, B, clone, and C, both are equally inexpensive, right? Also, we will be sharing an assignment with you post the part 2 of the session next Saturday. You can also ask any questions like we said, and join in and be very indulged in these assignments, because this time around you can win up to $50 worth of DOT if your project is worthy enough. A quick game again. You have exactly 500 seconds to do this. Follow us on Twitter if you haven't already. Retweet the pinned post, which is about next Saturday's part 2. And 5 of you will have, lucky draws winning a surprise that you don't want to miss. Now, it also gives us great joy to announce that the Polkadot India community has our own custom link to Polkadot Pathways. Now, Polkadot Pathways is an invitation-only community where you can learn more about Polkadot, Kusama, and Substrate. You can get recognized for your efforts with points and reputation, and you can also connect with other members of the actual global Polkadot community. So yeah, here's your personal link to Polkadot Pathways in the chat box for being a member of this community. So don't stop reading and learning with this comprehensive portal, right? And just again, on your screen are the winners from the contests we ran in our event yesterday. So we'll get in touch with you winners if you guys are around today, and yeah, for your wallet addresses. And we'll be dropping your winning dots soon. And with that, we come to a close to today's bootcamp. And we are very excited about next Saturday already. Do join in and do not miss registering with us for next Dot Friday as well. It's a gaming chapter and some really exciting speakers coming by. Hope this helped. Feel free to leave your feedback, like we said. Get in touch with any of us admins. And you guys have been fantastic. Have a great evening, guys. We'll see you next Saturday.